never heard about an ocean and you were studying these protein language models, you might kind of go, man, I wish I had a gigantic body of water that was subject to very different environmental conditions across its breadth, and that had a robust food web of microorganisms constantly reacting to environmental conditions. So yeah, if we didn't have an ocean, if we'd never heard of an ocean, in working with protein models, we would realize we needed to make one. So on the right, we got this great infographic, and it's kind of looking at 4 different marine habitats. So for example, the top left one is volcanic vents, right? Like kind of low in the ocean, you have these volcanic vents where you know there's energy and chemicals bubbling up from the bottom of the ocean. These are actually the only place in the entire planet where we have non-photosynthetic food webs. So there's actually like alternative food webs that metabolize energy from the volcanic vents, and they have an entirely different biochemistry. So if you kind of give one of these protein models the flavor of that ecosystem, it generates deeply different protein structures. It's so cool. So for example, the lower left one, that would be the intertidal zone, right? So that's the beach. And in the beach, the environmental conditions change very quickly. You know, industrial runoff, tides, weather patterns. The salinity, temperature, acidity of the intertidal zone is very volatile. So it could almost be thought of as like a random element, right? Like if you train a protein language model on the intertidal zone, you would get a sort of very creative thinking protein language model. Anyway, the ocean's unparalleled biodiversity and unique evolutionary pressures make it an irreplaceable resource for protein engineering. Like I said, if we didn't have an ocean, we'd need to build one for protein engineering.